Hello everyone, welcome back to Semgrep RuleWriting 201. I shouldn't say welcome back because you have graduated now from Semgrep RuleWriting 101. We're gonna stop that because that's an ad. Welcome back. Today, and in fact this week, we will be talking about Semgrep RuleWriting, as you may have predicted. I hope that last week's information and webinar was successful in transmitting rule writing knowledge to you, and if anyone had any ability to test that out in the prior week to try to play around in the playground, that would have been super cool. So let me know if anyone is able to kind of play around with stuff beyond what was shown in class last week. What we're going to do is we're going to get started with a few more interesting things about Semgrep RuleWriting involving the pattern operators that we saw before, the basic ones like any, all, not, as well as some new things, particularly taint mode, which is a big one because that's one of the coolest things that the Semgrep engine does and can really lead us to being able to find vulnerabilities in very like real vulnerabilities in code. We've been looking at a few representative examples now, but we're going to be able to find even cooler, bigger ones once we have access to taint mode. But enough talking on that front. What we're going to do is we're going to get started. So recap. So last week we talked about some RuleWriting, obviously. The things I wanted to remind you about from last week is that Semrep is about matching nodes and obtaining ranges. All right. And I'll show you a picture about that in a second, but that's one idea, is that we are parsing code to ASTs and obtaining the ranges of those nodes in the AST, the abstract syntax tree, the tree representing the program. Okay, and then remember also the idea that Semrep patterns and target code files are both parsed into trees, into ASTs, and then matched against each other. And by matched, we mean this kind of like thing where you kind of put them over each other and then see whether or not there's any part that matches in the way that much like a 5-year-old would. Okay, it's not very convoluted. Well, it's not very convoluted. The other idea is that Semrep patterns look like code. Remember, if you want to write a Semrep pattern, you don't have to know how to do any kind of thing other than write the code in the language that you're trying to analyze. If I want to write a Python rule, I write stuff that looks like Python code. We also learned about certain operators like metavariable and ellipses, which I will show you in a second so you can look at it, and the basic Semrep rule writing operators like any, all, and not. So remember this diagram here, we were talking about ASTs and ranges. If I had a Python program like this, we would say that the statement b equals 1 has the range of this yellow node, and the function foo has the range of this red node. But we can further decompose these nodes into their own subnodes, which are like the identifier b, the number 1, the identifier foo, the parameter a, and the expression a plus b. All right, it's all hierarchy all the way down. It's all ASTs all the way down. So we can always do this kind of decomposition until we reach a terminal case like B, okay? And this is really cool because it means that when we have our ASCs, we're just matching it against the tree. And in particular, I wanted to remind you about certain things in Semrep RuleWriting. So if we go to semrep.dev, and remember that we would go here to the playground, what we can do is if we go to the playground, we're going to see that we have a certain example. Let's actually get rid of that. And we can do things like, print. If I want to match any call to print, I would do something like print ... Because ellipsis is a special Semrep thing that takes the place of a parameter or argument to a function, and it matches 0 or more things. Whereas if I were to do print of $arg, I would only match on the cases where print has exactly 1 argument. Okay? Does this make sense to everyone? Does anyone need a refresher or a pointer into anything that we covered in the last week, 1 week ago, April 2nd? And if not, we will go with gusto and the grace of God into the next part of the lecture. All right. I don't see anything in the chat, which means either I'm having catastrophic network issues or no one has any questions. So that's great. Oops, that's not supposed to be the thing. All right. So let's get started, shall we? We're going to get started actually immediately with an exercise because I wanted to make sure that everyone is on board with what we're doing here. So we're talking about an initialization of a password authenticator, which we imported from couchbase core.cluster. And we are concerned with a very realistic use case. Here's a good one for you. Hard-coded strings. Raise your hand if you've ever seen somebody hard-code a string in production code and then that turned out to be a problem. I expect most of you would be raising your hands were we here in person. So this is a problem, and we're going to be able to find it with Semrep. And the reason is that we have this little feature here. There's a new pattern I want to tell you about. It's a what we call a literal metavariable. If you do a quote, quote, this catches any instance of a literal string in text. Okay, so let's try that out. Any string at all. So oops, that's the solution. Let's go here, and if we're going to click on this, we're going to find the exercise. Okay, so we see here that we import password authenticator, and we have a few cases where we call it, right? We have a case where we call it with username and mypass, where mypass is hard-coded. That's bad. So again, we have rule ID here. We have a case where we call it with getPass, the function, which is not a hard-coded thing. It's actually getting the password from like some kind of software. So this is okay. We have this case where it's the empty string. So let's say a special case is that if it's hard coded to be the empty string, that's okay. Because if your password is the empty string, God help us, like there's a bit of a problem there either way. And we have these two cases where we get it from the OS, from the environment, in which case we can't do anything about that. That is okay. All right. So maybe it's too early in the morning for me to ask you for volunteers to write this pattern here, but let's start out with the basics, right? So again, I like to do this in an iterative manner where we match a broader set than what we want to match, and then we slowly pare it down. So if I wanted to match any call to password authenticator, well, by Jove, I would write password authenticator left paren ... right paren, right? And if I did this, I would catch all of these bad cases. All right. Now I got to filter out these 4 without losing these 2. Okay. So what do I need to not do? Well, first I need to not match when the hard-coded string is actually the empty string. So let's do that. We're going to do this by combining 2 conditions. I'm going to combine a condition where I want to match any password authenticator and a condition where I don't want to match a password authenticator with the empty string. So we use all for that, right? Because all matches when all of its constituents match. So to do this, we'll do password authenticator and then one other password authenticator where we have user and then the empty string. And this looks like Python code, right? And I use this one meta variable here because I wanted specifically one argument before the quote. Although in this case, it wouldn't actually really matter. So this should get rid of one case, or actually gets rid of a couple cases. Oops, sorry, I meant to do it not. We would do not the empty string, and this will get rid of one case, right? Now we have to get rid of these 3 cases. Well, the problem is we are too permissive about what this password authenticator wants to match. We should actually only care about when these 2 cases have the hard-coded string. So, hint, hint, the language feature that I showed you a second ago, which is this literal meta variable thing, probably is going to help us out. So, what we'll do is we'll say not only do we match any dollar, or any ... we're going to match a username and when we have a hard-coded string of some kind. If we do this, we're going to see that we should match all of the things correctly. Why? Because this we can hover over this to see how it matches, but this password authenticator with the literal thing matches these 3 blue things on the right here, right? In particular, Semgrep is smart, and so it is able to constant propagate that my pass here is a hard-coded string. So with that, we're able to find hard-coded secrets before we pass them into our password authenticator. Any questions on this exercise? This should be pretty much coming out of the stuff that we learned last week, but with this additional nifty thing of literal meta variables, which are actually very helpful when you're dealing with whether or not there's like a literal case of a string in code. Cool. Okay, let's move on then, shall we? Let's get straight to it. So, wrong one. I'm hitting my my shortcuts and not used to that. Cool. Okay, so we have 4 pattern operators. We have pattern, not, all, and any. Right? We've looked at all of those, but we might be a bit more interested in having some other ones. So there are actually 2. If you look at this dropdown, there's actually 2 more that we haven't covered. So we're going to cover that real fast, and then we'll move on to something else. So there are 2 more called inside and regex. These 6 are the fundamental 6 pattern operators that are all you need to know. Every other rule is just a combination of these 6 pattern operators. Let's see. How would this work if the OSN was loaded into a var? Great. Christopher, I said I was going to send out the slides, and then I think I forgot to. So the full slides will be available on online. There's actually a link at the end of the presentation, so you should be able to see it at the end if you stick around. Thanks. So you're asking if we did this. All you're saying? X equals OSN pass, and then we pass it into here. And I expect this should work the same. Yeah, It works the same because we specified particularly, I only want to match password authenticator if the second arg is known to be a literal string, which osm.pass is not. And then we would filter out if it was the empty string, but this only matters for this case, so don't think about it too much. Does that make sense? Like, it doesn't really matter that we have this OSM being passed into a variable, because either way we know Semgrep only wants to find things that are literal strings. So that is not included in the package. Do not pass go, do not collect $100. Cool. Yep. All right, awesome. Good question. Let's move on then, shall we? So if we talk about inside, sorry, I'm just kind of bouncing around here. Inside is if we want to specify a match should be found only when it's inside of another. So for instance, I'm going to give you this case here. This is like YAML syntax, but in reality, you could use the structure mode editor and not have to do the syntax here. But the idea is that we'd have a pattern, which is that if we wanted to find a struct log.getLogger, and we want it to only do struct log.getLogger at the top level of a file. So we say it's bad if you have struct log.getLogger and you're inside of a function. Okay, let me just write that for you. Logger equals struct log.getLogger. I don't have a link to this, but let's just do this really fast. This would be bad here if I have logger.struct log.getLogger at the top level. So if I did an all, one of them is going to be logger equals struct log.getLogger, and then one of them is going to be inside of any function at all. And remember, the way that we write any function in Python is we say a function with any name, with any arguments, and any body. Because doesn't that mean a function? Or it doesn't, yeah, doesn't that mean any function? And this should catch only this one that's inside of a function. So that's one use case for inside, is like you only really want to use it when you know that this thing happens inside a class, happens inside a particular kind of function definition, what have you. So it's pretty useful, but keep that in mind as a thing in your toolbox. It only returns matches within that pattern, okay? And you use it when in conjunction with an all, because we want to maintain that both conditions must be true, okay? That's one of the operators. The last operator I'm going to tell you about is called regex. And you got to be careful about this one, because this runs into the same issue I told you about when we were talking about grep initially a week ago. Regex is the only exception when we talk about patterns matching ASCs. Regex does not. Regex matches text. So, for instance, if I did, print of 1, and I did print is printed, like hi, and I did print of printing, right? We know that if I did the pattern print, this as I've talked about at length, if I did the pattern print, I'd only get 2 matches. I would not get these 2 false positives. That is not the case if I did regex. Regex is going to be Control F. It's going to go and find all the instances of print in the literal corpus of the text. And this is not a great thing because it means that we've lost this property about ASCs, okay? So it's sometimes useful, but don't rely on it too much. It's actually more useful, as we're going to talk about in a second, when we're talking about metavariables. We're going to be able to use regexes to verify the names of certain metavariables and things like that, okay? But I wanted to let you know about this for the cohesiveness of your education. Yeah, so David, that's a good question. So you're asking about this thing that I unfortunately already deleted, which is that in the example of pattern inside, let's say we had def func ... and then this. How do we know that we want this foo that's inside of the function and not inside of like the parameters? This is confusing. So like this, for instance. The reason why it knows that it has to be inside the function and not specifically the arguments is because this whole range, actually I should do inside. This whole range is the thing that we match by this def. Inside says to be inside of the entire range of the function, and the entire range of the function is not just the parameters. Actually, this isn't matching as I was expecting it to. Maybe this will work instead. So this should work properly, but indeed, what should happen is that if this entire match has the range of this entire function, then we should be able to say that this foo can fall inside the whole thing. I don't know what was happening here with if we put foo here in the argue. Oh, I suppose that maybe the identifier foo doesn't match when it's in the arguments. Yeah, so like let me try actually. If I did regex of foo and I did foo here, and I did pass, I expect that this should match. Yeah. So indeed, it doesn't care that it's just in the body. It could be in the parameters, and that's because the entire function is what we match here, and we're just saying that we have to be inside the entire match. Does that make sense? It all comes down to the range of the function as opposed to the range of the ellipsis. Cool. All right, great. I feel like I probably repeated myself there a little bit, but I'm glad that makes sense. Regex, be careful. You know, there be dragons, okay? You got to be careful when you're walking around with just using syntax, because the whole point of semrep is that it is a semantic rep. So we have to make sure that we're getting that all in one, okay? All right. So now we're going to talk about some advanced stuff, conditions and focusing. So we talked about how to match things. There are actually a lot of use cases for when we not only need to match, we need to particularly not match. Because again, what does false positive mean? False positive means bad, scary. You do not want false positives in your matches. You do not want false positives in your security workflow, because guess what? It's going to waste your time. It's going to waste your developer's time. It's going to waste time and money and time you could have spent on a beach in Cabo, okay? So don't do that. So what we're going to do is we're going to talk about how we can filter out matches based on particular conditions, okay? We're going to talk first about this one called focus. This one doesn't filter stuff out, but it makes things more particular. So let's talk about this. If I did a pattern where my pattern was, and I'm sorry, I have to write this out again, this def func thing where I match any function, I can add a condition where, let's suppose I don't want to match the whole function. I want to match just the name of the function. Well, in order to do this, I would really want to match this $func, but I have to maintain that it's still attached to the function. What I'm going to do is I'm going to click this little button here called Add Constraint. And I get this little menu here with 3 new things. Don't be too scared. We'll talk about them all. But focus is the thing that lets us focus in on a particular meta variable. It lets us change the range of the match to one of the meta variable's ranges. So if we do this, we're going to see that the range is now the bar. Why? Because this whole thing, this whole def func matches the whole function, and then we focus in on to only care about the $func. This might seem weird because we really only care about, like, it seems like we should really care about whether or not a match happens or not. And this doesn't change whether or not the match happens, it just changes the range. This will be very useful for us in taint mode later because we're really going to care about the ranges of our matches. Okay? So focus lets us say, okay, I really care specifically that I want the match to be on the function name or what have you. We can only focus in on meta variables though. Okay? This is just some UI stuff on how to do that. I already told you that. Okay. Let's do this exercise here, where what we're going to do is, and this is going to be, for you Rustaceans in the crowd, this is a Rust example, all right? Cool. So I have this Rust program that is using this framework, I guess Rocket, that is maintaining some kind of web application, okay? And I have a few routes, okay? These are like your basic like web app routes that are being, dispatched to. And this one, for instance, is at slash. This one's at slash subtract, which is spelled incorrectly, which is interesting. The thing you got to know about this is that there are a few ways to do this correctly. One secure way to do it is if your root has an argument that is of type secfetch metadata, okay, that is good. It's going to do some like security thing that like validates the arguments. It's fine. So the root is safe if it has secfetch metadata as an argument. The index root, which is to say the root that is slash, is also always safe. So this is okay. But this one is not the index root, and it doesn't have secfetch metadata, so it is vulnerable. Multiply has secfetch metadata, so it's fair. Okay, it means no match. And this get also has secfetch metadata, so it's safe. So how would we do this? All right. Well, based on what I've told you so far, what's the first thing that we do? What's the first pattern that I write as I'm iteratively trying to write this rule? There's a first thing that we should try before anything else, just to get our bearing and to make sure that we know what's going on, and then we can improve upon it as we go. And if you don't read Rust, don't worry about it, because the Rust code's right here. You should be able to, by analogy, kind of write this thing. Anyone have any ideas? You can either speak now or not speak now, and then hold your peace until the next time that I ask. So, one idea I like to say is let's always start out by writing the thing that matches a bigger subset of what we want to match, right? So how do we write a pattern that matches Rust functions? It's going to look like a Rust function. So it'll be something like this. fn $func ... maybe we have a return type where the input, the inside body of the function is anything. Does that make sense? So this is going to match a bunch of things we don't want it to match, right? In particular, it's also going to match these functions down here. And we don't want to match these functions because these are not the roots that we care about. So first off, we're going to maintain that actually, we're going to say that it should be only hashtag get of something. If this is true, then we're only going to match the roots. So this should filter out these guys down here. And we still have a few false positives, okay? We have one false positive in particular. So what we want to be able to do is say that it's not the case that it's vulnerable if it has an argument that says sec fetch metadata, or an argument of type sec fetch metadata. So I should say arg. And if I do this, well, we actually already, sorry, let me do it this way. Let me do an inside where we're going to match here, and then we're going to say any function. So I think I went through that a little bit fast, but I noticed that we weren't matching here, and actually I think that we should have been. So basically what this is saying is if I have any function at all, that's what this matches, and it's inside of a root, that is to say it has this annotation of the hashtag get, let's match it. And then in particular, sorry, this is supposed to be a not also, if it's not having an argument of sec fetch metadata, then let's filter it out. So we no longer match this multiply because it has an argument of type sec fetch metadata, and we are no longer matching this add, which has an argument of type sec fetch metadata. That's good. This is what we wanted. And the last thing we want to do is we want to be able to say, okay, we should match here. Oh, I see what's happening. The rule ID is on the wrong line. Rule ID only checks if a match happens on starts on the next line. So if it's here, actually is a bad thing. It's supposed to be on the next line specifically. So this is good. This is good. We don't match here. We don't match here because of the argument. Here we do match because it doesn't have the argument. But here we shouldn't match because of a small thing I said earlier, which is that we don't want to match the index, which is the root that maps to slash. So we say not, and we do not want to match if it's a get, and then this get is actually on slash. And if we run this, wait. Oh, sorry, here. We don't want to match if it's not the index, and it could be any function. There we go. Yes, we could have also used a Leo, you're getting ahead of me. You're like 5 steps ahead of me. What? Oh man. All right, yeah, you're way ahead. Yes, we could have used a meta variable focus, and in fact, that's exactly what I was about to suggest, because we're going to change the range of the match to the range of the name. Actually, you know what? I made these exercises a little while ago, and I begin to remember why I put the rule ID on that line, and it's because the intention is that we're supposed to match the name of the function. So what we can do is we click this constraint button. Down here there will be a focus, and we add $func is the thing we want to focus on. And now we will match on the correct line, which is after the annotation. Yeah, good call out. I presented this workshop a little bit ago, and I was wondering, why is this rule ID on this wrong line? It turns out actually the enemy was me in the past. But this is indeed how we'd write this rule to check for these safe roots in Rust. Does this make sense to everyone? We kind of went through this one kind of quickly, so if you have any questions, now is definitely the time. I'm sure someone else has the same question. But the idea is simply like kind of how I put it to you in natural language, which is I want to match, a root. Okay, there's 3 conditions, right? I want to match a root. I want the root not to have a sec fetch metadata arg. I want the root not to be the index. And then also, I guess maybe a 4th kind of like pseudo condition is I want to match the function name specifically. Okay, seems no one has questions, so let's move on. Great. But let's talk about now filtering out matches. I talked about that last example didn't really have to do with filtering out matches. It had to do more so with like focusing. Meta variable conditions are conditions we can place on a pattern where we will filter out anything where the pattern has a meta variable that does not fulfill the condition. Okay, and there are 3 kinds. Meta variable pattern specifies a meta variable has to have a pattern inside of it, inside of the range of the meta variable. Meta variable regex specifies that the meta variable's match has to match a particular regex textually, like syntactically. Okay, And then meta-variable analyzers, which we probably won't get to today, but I can tell you about it, are specific kind of validators. They look at the range of the meta-variables match, and they run particular things like, oh, is this a high entropy string? Does this look like a regex that's particularly susceptible to redos? Okay, which is not something you could write with a Semgrep rule very easily. These kinds of like built-in validators, like these functions, are kind of provided to you by Semgrep. And then this last one, which is really cool, which is the identifier matched by this meta variable have a particular type. And this one's a bit different than the other ones because it's actually a bit more complex. This makes use of Semgrep secret sauce, some type inference information. Okay, these are the 4 kinds of meta variable constraints, but these are how we're going to filter out false positives because we'll be able to enforce particular conditions about our meta variables. Okay, so to do this, we can just take these meta variable conditions from here. So if we were to pop up one of these constraint guys, we would go down to meta variable, and then we could select from this drop down 4 different conditions, which is when the meta variable contains this pattern, matches this regex, fulfills this analyzer, or has a particular type. Okay, it's not really different in that way. So that's how you can do it in the UI. All right, we're gonna go to this Ruby case, and this Ruby case, if you don't read Ruby, don't worry about it. Neither do I. But basically, we have some classes. These classes subclass other classes. I want to let you know that application controller as a class is safe. If you subclass from it, if you have a controller subclassing from application controller, you're safe. Also, if you have a controller subclassing from action controller : base, that is also safe. These 2 guys are safe. But if you are not a controller, that is also fine. We are only trying to find controllers that don't subclass from the things that we want to subclass from. Okay, so we're trying to find, for instance, bar controller is a controller that subclasses from a controller that is not either of the 2 safe ones, right? We also have ZOMG controller, which doesn't subclass from anything, so this is also a flag. But protected controller and application controller both subclass from the correct controllers. Okay, but this class here, whatever, is actually fine also, because it's not a controller. We only want to find bad controllers. So I said the word controller a lot, it doesn't even sound like a word anymore. Let's think about this. Does anyone have an idea for what the very first thing we can write, how to match any Ruby class whatsoever? What do you think I'm going to write next, based on the fact that it probably looks like Ruby code that you have right in front of you on the right here? Should be like if you kind of squint your eyes and you put an ellipsis into the right place that looks like it wants to go to, we should probably be able to do this together. So any ideas? Okay, let's try that out. Class, $class, oops, that's weird. No, end. Yeah, I was shift clicking. If we do this, I believe you're correct. I believe this should match any class. Great, good job, Daniel. So now we have a match on everything. Let's cut it down to not matching everything. Remember that we only want to match controllers. Here's what I'm going to do. First off, right off the bat, to make that happen. We don't know what class is a controller because that really depends on how you use it. But let's use a heuristic. And this is what a lot of false positive reduction is about. It's about heuristics that work well in practice. Let's say that any class that ends in controller probably is a controller. So what does that mean? I want to enforce that $class, the name of the class. Maybe I can call it class name. I want to enforce that class name matches a particular regex, and it matches the regex controller. If I did this, I should find that the first 4 matches should stay. Does that make sense to everyone? What I've done is I've used a meta variable condition to filter out these classes that are fine because they're not controllers. It means that we don't care about them. Now the only thing I have to do is I have to enforce that it's okay. We want to filter out the cases where we subclass from either of these 2 classes. Okay? So there's actually a couple ways I can do this, but the first way I'm going to do it is I'm going to put all of this underneath an all, and I'm going to add a not. We want to not match when it's a class that is subclassing from application controller. If I did this, we would be able to filter out, sometimes unknown API error happens. What we're going to do is switch to turbo mode. Sorry. I I think that turbo mode sometimes has issues. What we're going to do is we're going to go here, and we're going to go to turbo equals 1, and we're going to turn that off. Sorry, sometimes there's transient errors with the networking, and then this happens. All right, so this will work for us. All right, I'm going to quickly reconstitute everything that I just wrote, which shouldn't take too long, and then we're going to redo that. So we want to say $class name, and then we want to maintain that it matches .star controller, and then we wanted to filter out the case where we had controller or class name subclassing from application controller. Hopefully the transient error should no longer be here. We are currently getting an unknown API error. That is unfortunate, and sometimes that happens. But basically what would happen here is that we would see that we would no longer be matching this class, which subclasses from application controller. This should probably go away in like a second here. And then, well, furthermore, what we'd like to do is we'd like to filter out this action controller : base. So we're going to do the exact same. Oh, sorry. This is actually a not 2. I keep forgetting my nots, which is really important, actually. You should probably not do that. So what we're going to do is we're going to put a new one here, which is that we maintain that we think that it's okay. We want to filter it out if we subclass from action controller : base. Okay. All of these conditions together should make it so that we're able to successfully match if it's working. Yes, it's working now. Sorry about that. Sometimes that happens. Okay, so based on this, we now match the ZOMG controller, which is a controller that does not properly subclass, and the bar controller, which is similar. And we don't match these two, which are okay, and we don't match these two, which are okay. Any questions on this example here? And does everyone see like the use case of this? Like, not only like I want you to see why we're how we solve this problem. I want you to see why we're solving this problem, right? Like, forget Ruby for a second. Generalize this to like any kind of situation where you have some kind of subclassing situation, where you have something where you want to use some kind of heuristic to apply to the name of a meta variable. Okay, this is a generalizable example, is the thing I'm trying to show you. Cool. No more questions. Cool, let's move on. Great. Okay, so the final condition, well, that's not the final condition operator. One other condition operator we haven't talked about is comparison. It lets us say something about the value contained by a meta variable. So for instance, if I wanted to write a regex to check if like a particular meta variable is greater than like 90, that'd be kind of difficult for me to do with purely textually via regex. Comparison lets us write some like pseudo Python code, not real Python code, like Python looking code, to see whether or not it is the case that a particular condition is satisfied by the value contained by the meta variable. So for instance, I have this example for like Terraform. If we have a retention in days where the days is less than 365, that's bad. It actually ends up being not SOC 2 compliant. So what we want to do is we want to catch retention in days where the value of the days is less than or equal to 365. We can write that via just writing this meta variable condition here. Okay, it's just as simple as that. So what we're going to do is we're going to look at this example where we're trying to see that generated RSA keys are sufficiently strong. Okay, and what sufficiently strong means in this case is greater than or equal to 2048 in value. So I guess I won't ask you to pitch in here. What we're going to do is we're going to try to match RSA.generateKey where the second argument is less than 2048. Okay, that's the simple problem statement. So what we're going to do is we're going to call generate key. We can call it on ... and notice that it matches both, or we can just jump straight to the point and do $reader and then $value. Okay, this will also match both. Now I want to filter out the case where the value is too small. So what we're going to do is we're going to say add constraint. The constraint is on the meta variable $value. And we're going to use comparison. Oh, sorry. Here's this one. Sorry. It's not a meta variable condition. We're going to use comparison, which lets us write an arbitrary Boolean expression. And we're going to say that $value needs to be less than 2048 to be bad. We want to maintain that we only keep the ones that pass this condition. If that's the case, then RSA.generateKey of 1024 is going to be a problem. I'm sure that 1024 plus 1024 actually is going to be fine. We're going to do some constant folding here. Yep. So here we find that only when the generate key has a sufficiently small value do we match. Okay. I think that should be pretty clear, but it's pretty cool that we have this comparison tool available to us. Cool. And if no questions, I'll move ahead. All right. With the time remaining, I'd love to talk about taint mode. So Is anyone here familiar with like taint analysis, like source sink analysis? Has anyone here heard of it? Used it maybe in like a different tool? Who here knows? Okay, yeah. Taint analysis is pretty cool. We've been writing what's called search mode rules, where we just search in CodeQL. Yep, that's one example of how you could use taint mode. Search mode rules kind of just like find particular patterns in your code, but they don't really link stuff together. What you find is that in security, like the vast majority, I'd say, well, not vast majority, but look, a lot of problems end up being as simple as bad data goes to bad sync. That is the vast majority. Well, I should stop saying vast majority, but it feels like the vast majority. So we use a technique in static analysis called data flow analysis to solve this, but taint analysis is just saying we have a source which has some sensitive data, and we also specify a sink, which is where the bad data goes. It's a sensitive site, and we're saying that it's bad if both link together. It's like a two-parter of a rule. Okay, not only do we have to match the source and the sink, they have to somehow link the data together. So let me give you an example, okay? Let's suppose we have this data flow example in Java where we have a main function that takes an args via string args array, okay? And what we do is we say, okay, this is our sink. The args is our sink. And the thing about taint is that taint is sticky. If something is tainted, it will taint the stuff around it. So if we assume that args is tainted, because it's the way that we pass in arguments to this Java application, then we are concerned with whether or not this args taint reaches the runtime.getRuntime.exec. Why? Because we don't want people to arbitrarily run exec on our code via passing in stuff via the command line. Okay, this could be easy code execution. All right, that's bad. So common sources, for example, are like URL parameters in your like roots, cookies, user input, like args here. Common sinks are if you're doing SQL queries, that will be easy SQL injection, shell commands, or in today's AI-focused world, okay, anywhere where you call an LLM. Okay, that could also be a common sink. All right. So let's trace the flow of taint. So as I said, let's assume that the source args is tainted because the source is the source of taint. If that's true, then the next usage of args of 0 should be tainted, right? Because it's using args. And if this is tainted, then the identifier we assign it to should be tainted. And then if CMD is tainted, then this use of CMD should be tainted. And this lands inside of the sink, which is the exec method. Okay? That is bad. So this is a way of us showing, does the blue go into the red and make purple? Yes, it does, and purple is scary. Purple is really bad. Purple is scary. So that's a finding. That's what taint mode means. Does the source go into the sink? And this is actually exactly how Semgrep does it internally. Okay? We specify a source via a pattern. We specify a sink via a pattern. And then we do a bunch of data flow analysis math to figure out whether or not the source is able to taint data that eventually goes into a sink. And if that's true, we get a finding at the sink. Okay? So to write a taint mode rule inside of structure mode, what we're going to do is we're going to go here. Let's start a new rule maybe. Oops. Start a new rule. And what we're going to do is we're going to click this button here, this little tab, which says taint mode. So this lets us specify a source, or sources, sinks, and sanitizers. And then we're going to do it just there. Okay? So, to reflect this example, maybe, okay, well, I can't copy it over. Maybe this I can copy over. I'm going to copy this over, and we're going to see this example. Oh, jeez. Sorry, I'm, if you don't mind me, actually, it doesn't even matter what this is called. Cool. Okay, and then there's a few problems with this, copy and pasting this because of my slide setup, and sorry because I didn't prepare this ahead of time. I should have just made a new link, but this will work, and then we should be able to do this now. Okay, so let's suppose that we want to say that like a source for our code or example. Oops. We're gonna write it here. We're gonna do a pattern in the textual form. We're gonna say that a particular source might be if I have a public static void main, the arg to that string args, that is itself a source. And in particular, what we can do is we can say patterns, and then do pattern. What we're going to do is we're going to want to focus on just the range of the args. What's really important about this is like, if I were to just say that this is the source, right? And then say that, you know, runtime.get runtime.exec, this is the sink, what we'd find is actually we would match, or wait, this is going to be a, sorry, let's go back to the example so because I think I actually have something prepared here. Sorry, so this is the example. I was just typing this out even though it's already here in the slides. Go figure. If I wanted to write this taint mode example, and I wanted to say, let me match on void main, where I have an args argument, and I focus on the args, and then I pass it into the CMD, this would be exactly the example I just showed you. It would mean that our source would be the args, and then our sink would be this whole thing. But the reason why we put this focus here is really important. If I didn't have this focus here, my source would be the entire range of the void main, meaning that anything inside of this function would be tainted. That doesn't, it means that we would match even if CMD wasn't passed into the getRuntime. If we literally called runtime.getRuntime.exec with 4, it would produce a match because the range of the source would be this guy, and then the sink would be inside of it. The way that it works is that when you specify the range of a source, any identifier inside that source becomes tainted. Okay, anything. So we want to make sure that our sources are small and our sinks are contained to only the call that is problematic. I realize that's not like as visual as I wanted it to be. Does that make sense to everyone? Or we can also I can also try to show you here. But does that make sense, kind of what I'm saying here about the ranges being important? And I think, string $args, I'm pretty sure this is exactly the same pattern as here. Okay, sorry, I forgot to change the language to Java. That's why it wasn't syntax highlighting correctly on the right either. So this will match, right? So this is if I didn't do the focus. This would match, but also it would match if I literally did, like, sorry, I have to move around my stuff. Runtime to runtime of like 5. If I did this, I'm pretty sure this should match. And the reason for that is because this source here is the whole function, meaning that 5 is tainted, meaning that exec is tainted, meaning that CMD is tainted. Everything inside of this function is tainted, which is vacuously, like, it's not helpful. That is not even representative of the real taint, which is only coming from these args. Okay? I don't see anyone asking questions in the chat, so we'll move on. But this is a really important thing to know when you're writing a taint rule. The range matters. And stop me if I'm like hammering stuff into your head that like you feel like you've got it. You're like, Brandon, you know, I understand. That is useful feedback too. Feel free to pitch in at any time. Okay. What I want to show you next is sanitizers, because taint, again, as I said, is really sticky. You taint something and it taints all the stuff around it, but sometimes we have data validation functions that kind of sanitize the taint, as in they end the taint. So for instance, if I had this args thing, I might have a function called filter file path that actually takes in a untrusted user input, like you know, a file path, and then it sanitizes it and makes it properly, you know, a path. Right? Because like if we wanted to do rm plus something, we wouldn't want to do rm, you know, dash rf, you know, tilde, right? That would be really bad. But what we can do is if we had a custom function called filter file path that made the path sanitized, we would not want a finding here because we have a trusted sanitizer. Okay? So to do this, Semgrep can easily do this because what we can do is extend our rule with a custom sanitizer that we know verifies that the input is not dangerous. So here's our new trace, okay? If we had a source here, a sink here, and a sanitizer, which is the filter file path function. Our source will be args, which is going to taint args of 0. And then it's going to, but this taint is within the sanitizer filter file path, which ends the taint. No more taint. The taint never continues because filter file path just completely ends its existence. So we don't make it to CMD, we don't make it to exec, which is the sink, so no finding is produced. All right. So let's see how we would do this in Semgrep. Well, what we would do in Semgrep is we would just add a sanitizer. And I know the syntax for this is not like super familiar, but the idea is that we would just add a sanitizer that says filter file path of yeah, and I think that this should probably be able to match, but oh, you know what? We're not using structure mode for the time being, but kind of imagine with your mind this syntax. So we just add a sanitizer that says filter file path, and then that's all, and then it's able to properly sanitize the taint. If that makes sense, we're going to go and do this exercise now, which is this kind of similar thing. Okay, where we're going to be doing this thing where we have a few different cases, all right? This runtime example has a few HTTP servlet requests, and these HTTP servlet requests are being used to get params. So we take this rec, and we do rec.getParamCMD. So this CMD is user controlled, and it makes its way into exec, which is bad, okay? But this CMD actually makes it into a .exec on something that isn't of type runtime, okay? We only care about the runtime.exec, and this isn't a runtime.exec, so no match, even though this is user input, okay? This rec actually ends up not being used at all. We just do runtime.exec on a different CMD, which is not the HTTP servlet request. So this is actually fine. I only care if the servlet requests taint makes it into the runtime exec. And then this one, we do get the parameter, which is user controlled, but we have a sanitizer, which ends the taint, so we don't produce a example here. This one's a little bit different than the search mode rules because we can't just simply write a search query and then just like have it work. There's two parts to it. So first, what I'm going to do is I'm going to let you know, okay, let's focus on the case where we want to taint. What do we want to taint? We want to taint this servlet request, right? Because we want rec.getParam of it to end up being tainted. We want the taint to be sticky and applied to the argument. So what we're going to do is we're going to use a new feature that I'm going to tell you about right now. There's a metavariable type condition, which lets us enforce that a metavariable has a particular type. But you can also write it inline in Java. If you write left paren type name metavariable name, it's going to enforce that this only matches metavariables where it has this type. Okay, that's just like a Java feature that like is implemented in Semgrep. So what we're going to do is we're going to write, I'll just do pattern. If I did HTTP servlet request $rec, and then let's say that the sync is like exec, and I'll fix this later, rt.exec, okay? And I'm going to write a more general rule and fix it as we go. So this will yell at me, but it's okay because we're going to go through it and make it right. Okay, so we properly match in some places, and we erroneously match in two places, okay? This one we erroneously matched because we didn't constrain the runtime.exec to be only on, or rt.exec to only be on if the thing has type runtime. That's one thing. The other thing is that here we didn't account for the sanitizer. So to write a sanitizer, we're going to do this thing called pattern sanitizers and write a pattern where the pattern is any call to sanitize is a sanitizer. And this is not like born out of like the Java standard library. We're assuming that we're working in like a Java program or a Java code base where we have a custom sanitizer called sanitize. Maybe I could change it to like my custom sanitize. And the strength of this being that like really like security should be tailored to your organization and your coding practices because rules are not one size fits all. They don't match your particular sanitizers, your particular internal libraries. So my custom sanitizer maybe. So this is properly going to not match here, and match here. What it's not going to do is it's not going to constrain this. I might be moving a bit fast, but does anyone have an idea for how we're going to constrain this rt.exec to only happen on things of type runtime.exec? Like the .exec should be coming from something of type runtime. Spoiler alert, it has to do with something I showed you like 45 seconds ago. Does anyone have an idea? What could I write instead of this $rt.exec pattern? Rest assured that the answer is not unknowable. There is a thing I'm pointing you to. Maybe give you some time to think about it. What do we do here with like this servlet request? We maintained that the argument to that we want to taint has to be of type HTTP servlet request. So what we can do is, maybe you didn't know that you can nest this, but we can actually put this in here and maintain, yes, indeed, David, good job, that runtime RT means that we have to be calling exec on something of type runtime, okay? I'm asking this because I want you to be able to write these rules yourself. You know, I want to give you the power to like, when you have some kind of issue in your own code that's similar to this, write a rule that will just go and fix it, okay? And this will properly give us the match only here and not on these three false positives here, okay? And I think this should make sense for why this is useful, right? We care that like we don't sanitize the input. We care that the input is well formed, that it comes from the rec, the HTTP servlet request rec, and that we want to care that indeed we are calling the exec method that is vulnerable, the runtime exec method. Maybe I should show you also that like if we added a new function or we had like an arg that was like, I don't know, string arg, you know, if I just pass this arg into exec, this is not going to match because we specifically specified that we wanted pattern sources to be only the rec. So we could tune this rule further if you cared about that use case, but this is also great because you wouldn't care if the arg was like int. You know, that would also be fine. So up to you, but rules are constantly evolving, constantly changing based on your particular needs. So that is how we would do taint with this sanitizer right here. And then this final example we're going to do is going to be finding cross-site scripting in Express.js. Okay, and as soon as you hear Express.js, you should be like, oh man, we gotta you know be careful about that. So how do we use taint mode to simplify this? Okay, well let's look at this. So let's go through the examples. I'm going to identify to you right now. Whoops. There are two problematic functions to call. That's res.write and res.sendFile. Because if someone reuser controls the stuff that they put in there, anything could happen, right? In particular, the thing that we want to look at is we have in Express.js, we take in these app roots and we have rec, which is going to be our source of like people's user input. And you could get the data out of rec a few ways. You could do rec.params to get out the information from rec, or you could deconstruct the rec using this const kind of syntax. This is actually kind of problematic because this is going to be a little difficult for us to figure out. We're going to have to be able to really make sure that this is correct. And the last thing, which is that we have a clean XSS, which is like our, you know, is our sanitizer. So, okay. Let's start with the sync, which is the first thing I told you about. So let's just say like .res.sendFile, and we're gonna use a pattern either, which is the analog of any I showed you. I'm sorry, I know the syntax is a little bit different, and that's because I would be using structure mode, but in the structure mode it's any. So first we're gonna identify that our syncs are sendFile and write, okay, and then our source. Let's say that we have app.getBar. We're going to say that the rec argument is going to be our main thing. So like app.get, I don't care what the root is. I care that it has a rec and a res, and I don't care what's inside here. So ... But what I do care about is I care that I use a focus to make sure that the range of my pattern, my source, is only this. For the same issue that I identified earlier, I don't want the range of the source to be too big. So we do focus meta variable on, I'm going to change this to $rec and $res. Actually, let's just do $r. And I'm not going to be too strict on why that is for a second. Okay, so what I've said is that our sources are any kind of root and only the rec argument to your root, and the sync is sendFile and write. So okay, this makes sense that we're getting these particular issues. But actually, one last thing, which is that params.file is tainted, but path.basename on the file also acts as a sanitizer. So I think that we might be a little too permissive if we just taint rec in general, right? We get this match, which is good, but we also get this match even though we cleaned it with XSS, and we also get this stuff even though we did other stuff, right? And we don't really want that to be the case. So what we're going to do is first we're going to add a sanitizer, pattern sanitizers, and we're going to add a sanitizer that is clean XSS. So this will remove one of our false positives, which is this one. Okay, so now this is matching properly, and this is not matching properly. But we're not supposed to match this path.basename. So there's a few ways we could do this. We could have pattern, and we could have path.basename itself be a sanitizer. This would be one valid way to remove this. I actually, if I recall correctly, this is not the intended way. I'm kind of making it up as I go. I don't think this is the intended way that I originally had of solving this, because it's kind of a lot of effort if you think about it, to enumerate all of the path.base names, you know? So one way we could do this is if we peek at the reference solution, hint, hint, that this exists. What we could do is we could go and see, actually, I care specifically about rec.params as one of my sources, and I care specifically that I destructure out the params as my rec. And then implicitly, this will mean that actually, no, it is pretty much the same solution, sorry. I didn't see these sanitizers earlier. So yeah, this will work pretty much. We can make it more particular if we say, oh, only rec.params should be tainted as opposed to any rec thing. And then we could also add in that we want to specifically destructure the params via either doing dot or by using this record destructuring thing. Okay, if that makes sense. Cool. I have just a little bit of time to tell you the last thing, which is autofix. Remember that like guardrails is two things, okay? When you're trying to enforce some kind of secure guardrail in your organization, it is one thing to tell the developer that they're wrong, but usually, I'm a developer, we don't take too well to being called wrong, okay? It's not just enough to tell them they're wrong, you have to tell them what they need to do next. Remediation and guidance is the other half of the battle. So autofix is a Semgrep feature that lets you write a rule that automatically proposes a fix for what you should fix the code with. So in the UI, we would say, if we want to go back to a new rule, in the UI, what we would do is we'd first successfully make a new rule, and at the bottom of this little rule info thing, there's an add fix. So let me give you a concrete example. I work in a shop where we have a bunch of prints, and we want to replace it with logger.info. This is a really low-key example, okay? It's not too complicated. What we would say is we'd say like $arg, and we want to replace print of $arg with logger.info of $arg. If I did this, what we should see is that we produce two matches. I want to run it. And we produce two matches where each of these matches has a fix associated to it, where this fix will auto-fix it with logger.info of 1, and this will fix it with logger.info of high. So I can click it, I can accept the fix, and then I can rerun it maybe, because now the information has changed, and then I can rerun this new auto-fix here, and accept the fix again. If you run this from Semgrep CLI or in a CI, it will automatically suggest the autofix in like a PR comment to like the developer if you run it via like in your CI/CD pipeline. So this is a cool thing that we could do. We could also do it with like multiple arguments. So if we had like print of 1, 2, 3, then we can say, okay, logger.info should be replaced with this thing, which I didn't get to, which was called an ellipsis meta variable, but essentially is a ellipsis that has a name. And if we did this, we could also autofix this. And this will work properly. So that's another really cool thing about Semgrep is you can kind of use it for like mass code refactoring, or you can even just use it for enforcing some secure practice. Okay, I have an example here that we're just going to peek at the solution for. So this is the replacing with logger.info thing. But we could like enforce that people use an add secure cookie method instead of an add cookie method. And then one last thing I'll tell you, which is that according to research, and I'm not being playful when I say that, actually like legitimately, rules with autofixes have 50% higher fix rate, which is to say that like people make a fix that removes the finding than rules without autofix. So this last solution thing here, I'm just going to show it to you really fast because we're kind of out of time here, but basically if we had people using rec.addCookie inside of a cookie helper, we could add a fix, which is to say that we should replace it with rec.addSecureCookie, right? And then this would basically let us replace all of the instances of rec.addCookie with a different kind of more secure method here. So it would show like this. I think I forgot a semicolon, but this thing, yeah. So it's just as easy as that. And then adding autofixes is really important to making sure that like not only do you say, hey, like this is a bad thing, but to the developer's facing standpoint, you know how to fix it. Okay, that is the end of our rule writing seminar series with me, at least. I hope you got something out of it. I really hope that today wasn't too fast because we kind of did a lot of stuff. Craig, when an autofix fires in Semgrep CI, it adds an automatic suggested commit. So you can accept the commit or not accept the commit, and it'll automatically commit it to your branch. We've covered a lot of stuff, and not even all the stuff, but everything starts and ends with Semrup rules, and there's a lot of cool stuff that you can do with it, but these are really the basic blocks, the building blocks that make up writing a Semrup rule. Everything after this is just iterated application of the stuff you've already seen. So if you want to, you can pull Semrup from brew install brew install Semrup, don't brew install brew, that doesn't make sense. And then you can scan your code base with the default rule set, or you can write a new rule to scan your code today, okay? And you can do that to find org-specific stuff that you care about, okay? This is all, again, about secure guardrails, about being proactive and fighting the fight from the beginning. Stop firefighting and start erecting guardrails now. We're not going to get to a couple of these things. Here's some stuff that you might hear about, which we didn't get to, but you can explore on your own. Taint propagators, taint labels, generic mode. Feel free to read about those or ask me any questions about rule writing. And here's some further resources about Semrup rule writing. We have a Semrup Academy, which is online. You can look it up, Semrup Academy, which has some excellent free resources, completely free for like rule writing, custom rules, functional programming. My course is on there as well. Peter DeKremer, one of my coworkers, also has a YouTube channel where he produces videos about rule writing and about security. And oops, that's Slack. And then also my website, where these slides are going to be hosted. So if you want to, a little bit older of a version of these slides, but pretty much the same, will be at this link. If I copy this link and I put it here to everyone. Yeah. But other than that, that is it. I will not keep you any longer. Feel free to stick around if you have any questions. But thank you so much for attending this series. I really hope you got something good out of it and you are able to erect some security guardrails in your own organization. Thanks a lot.